Today we are going to look at 5 different methods we can use to compare fractions. These 5 methods are same number of larger pieces, greater number of same size pieces, benchmark comparison with same number of larger pieces, benchmark comparison on either side of the benchmark, and finally larger number of larger pieces. So first we are going to look at 2/17 and 2/19. The first thing I notice is that the numerator, or the top number, is the same on both of these fractions. The numerator tells us how many pieces of the whole are shaded or not shaded, depending on the problem. When the numerators are the same, we know to use the same number of larger pieces method to solve. All we have to do now is decide which pieces are bigger, 17ths or 19ths. And we can tell this by looking at the denominator. We know that 17ths are bigger pieces than 19ths. Since there are fewer pieces of the whole with 17ths, the pieces must be larger to account for the whole one whole. This means that 2/17 is greater than 2/19. Now we're going to look at comparing 4/7 to 9/14. Looking at these two fractions, the first thing to notice is that 4/7 denominator, or the bottom number, is 1/2 of the denominator for 9/14. Now, that being said, the first step is to multiply 4/7 by 2/2 to get a common denominator. 4/7 times 2/2 equals 4 times 2 is 8 over 7 times 2 is 14. Now we can compare 8/14 and 9/14, which is already listed here. Now both of our fractions have the same size of pieces, which we can tell by the denominator, as we said up above. So we know to use the greater number of same size pieces method. We are now comparing the numerators 8 and 9. All we have to do now is decide which of the numerators is the larger number, so we know which fraction has more pieces. 8/14 is less than 9/14, so that means that 4/7 is less than 9/14, because 8/14 is equal to 4/7. Next, we are going to look at 17/19 and 13/15. The first thing to notice about these two fractions is that they are both 2 pieces away from one whole. This means that we will be using the benchmark method, with the benchmark being 1. Since we have discovered that both fractions are 2 pieces away from the whole, we can look at these fractions as 2/19 and 2/15. This is where it can get a little bit tricky, because we need to think of these two fractions as the part of the whole that is missing. As we discovered in the first problem, a smaller number in the denominator means that the pieces of the whole are bigger. So when we compare 2/19 to 2/15, we know that the 2/15 is a bigger piece. We need to recall that we are looking at the missing piece of the fraction. So since the 2/15 is a larger piece, that means that it has more missing. So now we have to think apart about the part that is still there or the part that is not missing. Since 2/15 has more that is missing, that means it must have less that is still there. So we have now discovered that 17/19 is greater than 13/15 because there is less of it that is missing because it has smaller pieces. Now we will look at 24/7 compared to 44/15. For two fractions that have a smaller number as the denominator compared to the numerator, is the first method that I go to is the benchmark comparison on either side of the benchmark. I think of it first as a mixed number to find the benchmark. 24/7 written as a mixed number would be 3 3/7. And 44/15 written as a mixed number would be 2 14/15. If we use 3 as the benchmark, we can now see that 24/7 is greater than 3, while 44/15 is less than 3, because 44/15 written as a mixed number is 2 14/15, which is not quite 3, but it just about is. So we now know that 24/7 is greater than 44/15. Now we're going to look at 2/9 compared to 3/8. The only method that we have left is the larger number of larger pieces, which works out great for these two fractions. The first thing to look for is which fraction has larger pieces, and we can tell this again by looking at the denominator. 3/8 has larger pieces because there are less pieces to account for the one whole, so the pieces must be larger. Now, looking at the amount of pieces, which we find by looking at the numerator, we know that 3/8 also has more pieces along with larger pieces. If something has larger pieces and a larger number of these said pieces, it is pretty obvious that this is the one that must be larger. So, 2/9 is less than 3/8. We have now showed an example comparing fractions using all 5 of the methods that we used in class. Same number of larger pieces, greater number of same size pieces, benchmark comparison with same number of larger pieces, benchmark comparison on either side of the benchmark, and larger number of larger pieces.